Wait just 2 more minutes. Okay, we'll say that this is good, and we will start our presentation. So we're going to be discussing cultural constellations in astronomy, especially that of the non-Western and modern constellations. So when I'm talking about Western and modern constellations, this is what I'm talking about. As you can see, it's a very large map. There's a total of 88 different constellations with an average of 8 stars per constellation. It largely draws from ancient Greek traditions for naming the full constellations, and then has also been influenced through Islamic astronomy, which you can see through most of the names for stars, such as Alberio, Deneb, etc. Now, as many of you may know, this is the Orion constellation, and as you can see, Orion is like supposedly a person, the like hunter or whatever, and just because I'm putting this image to point out that just because that this is the sort of constellation system we're using does not necessarily mean that it is the best constellation available. When I ask you to identify which are the arms, many of you will not actually identify this initial area as a sword. You will think of it as an arm, and this is perhaps a bow. This is apparently supposed to be a lion's pelt. So it's not really reflective of like what we're actually seeing up in the sky, even if there is a fair amount of like cultural tradition associated with it. Now, what I wanted to show is that there are other constellation systems. This is in particular, here is the Egyptian constellation of Sa. For Egyptian constellations, from what we know, there's a significant amount of overlap between Greek and Roman astronomy, especially during the later periods of Egyptian astronomy. This is due to the fact that Rome, Greece, and Egypt were all like a part of the Mediterranean and were all in very close contact with one another. So that there was a lot of cultural exchange going on, even if like names weren't actually being transferred from one to the next. Here you can see Sa. Sa is the name of an old Egyptian god that was known as the father of the gods. However, eventually he became sort of absorbed by Osiris in terms of like what was attributed to him. And observing this, you can see pretty clearly, like you can even make out the funny little hat, the legs, the arms, and like the shepherd's crook, all very like much more observable than what was present in the Orion constellation beforehand. And what we know about Egyptian astronomy is that it has been present for like around 7,000 years. By the time of the third millennium BCE, they were already on the 365-day per year calendar. And they had 28 constellations with an average of 9 stars per constellation. So less constellations than what we have in our modern constellation system, but more average stars. And as you can see, some of their shapes were quite a bit more defined and easy to sort of make out when you know what you're looking for. Just a brief timeline of what sort of stuff that Egypt was able to accomplish in terms of astronomy. By 2580 BCE, they had already built the Great Pyramids of Giza. A really important thing about this is that the sides were all sort of aligned with north, south, east, and west. And there was, they used astronomy to make their measurements with this. And they had an error margin of less than a degree, which is incredibly impressive, especially considering how long ago that was. By around 90 to 160 CE, Ptolemy sort of popped up in Roman-occupied Egypt. He completely revolutionized Western astronomy for his time, published many books, made various models such as the epicycle and a deterrent, that were able to provide sort of qualitative, if not necessarily quantitative, explanations for why the planets and just other orbiting bodies were behaving the way they were. Obviously, now we know that the Earth is not the center of the universe, but for his time, it was very cutting edge stuff. Fast forward a couple hundred years, we have Ibn Yunus, who made various observations on the sun and solar eclipses. These solar eclipses would be used for hundreds of years afterwards. All the data that he took and made a ton of progress. Ali ibn Ridwan observed the supernova SN 10,006 and left the most accurate and detailed description of it that we had for a very, very long time. So those are a few things about Egyptian astronomy. We're now going to move over to Autumn for her part of the presentation.
Sounds good. So I will be focusing on East Asia, mostly China. So China and Mesopotamia were actually the two main sources of very early astronomical record. And what made China so important and unique is the fact that they did a very good job at keeping these kind of records safe and organized, and it was able to survive thousands of years. So right now we have over like 2.5 thousand years of good records, and they were doing astronomy for much longer as well. So in China, astronomy was kind of known as a royal science. It was very important. Astronomers were appointed by the emperor himself. And at first they had roles such as mostly recording time. And again, it was very important. The emperor himself had a cosmological temple and a ritual home, which included an observatory. So again, going very far back, they have a lot of accounts of both solar and lunar eclipses, actually having the first record of a solar eclipse in 2136 BC. And another very big event was in 1054 AD. There was a guest star that they called it, basically a new star that they noticed in the sky that was visible for a few days or for a week. And there were other similar observations made by astronomers in the Middle East, but not in Europe at that time. And it turns out that was actually the supernova that ended up creating the Crab Nebula. So again, the Chinese had very huge influence. They had one of the oldest observatories, which was Stonehenge, 12 Stonehenges, and also some background of accomplishments is that there is a scientist, Shen Kuo, living from 1031 to 1095, who was the first to describe the magnetic needle compass, as well as creating an accurate measure of the distance between the pole star as well as true north. And so to this day, very prominent in around the times of the Mongol Empire between the 13th and the 14th centuries. There is a big influence from the Middle East. Many Islamic astronomers came to China. They had, once they began interacting, there were many new instruments designed and ideas, and this ended up spreading into Korea. So yes, that is the influence that East Asia has had on astronomy.
Okay, next we're going to move over to Julian. Julian, what do you want to screen share on your end?
I could, but I think you have it. My slides in there. So, whatever. So I'm going to be talking about this astronomy in the Mayan Empire in Central and South America. And so first I'm going to apologize. I know there's a lot of words on this slide, but anyway, so at least you can read them. So they believe that the Earth was at the center of the universe and it was fixed and immobile, and that the moons, sun, planets, and stars were their gods. And I mean, obviously the sun and the moon were very important, but the Venus was the most important planet in their society, and it was associated with war, which I think is kind of interesting, coming from my Western background, where Venus is the god of peace, but anyway, or love, but anyway, they actually took very precise measurements of Venus's year relative to the sun, which they measured to be 584 days long, and now we have determined it to be 583.92 days, so very close. And as examples of how important Venus was to their society, they would arrange battles and wars to coincide with the movements of Venus, and they would sacrifice captured warriors and leaders when Venus was at certain positions in the sky. And another thing that they produced were folded books, which we call codices, which were written in the Mayan. They used hieroglyph language, which documents the movement of the stars and constellations. And this picture I have is an example of that, from where someone has put in the paper and annotated different hieroglyphs there, which stars they mean, and then some numbers to refer to how long things for different time scales. And if you go to the next slide, there are two more examples of codices, and the one black and white one, someone has annotated different significant constellations and other things in there. So that was a very brief overview of Mayan astronomy, but that's all I have, and I encourage you to look up more into that if you're interested.
So we are going to be taking a look into the Stellarium program again and looking through some of what we were just talking about. Just share my screen here. So one of the nice things about this program as well is that it has a pretty wide selection of overlays for different sets of constellation art. So as mentioned in, I think, the second talk, some of the constellations in the Arab sky tradition.
And so some of them that we can see, and I'm sure you can see them for yourself, some of them are called the whale, the hen, the turtle. And we also have some individuals. So we have the archer, the snake charmer, and the maiden. And I personally think that it's very creative to include these artistic versions. And you're welcome to use Stellarium on your computer or on via a web model or an app to see some of these for yourself. We're going to go through a few, but there's additional ones that we're not sharing today.
Yeah, let's take a look. We can skip over to Dakota, Lakota, and Nakota constellations.
And so again, we see a turtle and we see an elk. And we see the thunderbird. And we see one representing a fireplace.
I think one thing that's interesting that you'll see, especially if you pick up Stellarium and you take a look, or you look up online, so many sets of different constellations that the kind of level of like simultaneous occurrence of imagery happens is really stunning. Let's take a look at, we were just discussing Maya, which is also incorporated into Stellarium here.
And so here we see a somewhat entirely different set with some overlaps. Let's see, I believe we have, is it a shark?
Sorry? Yes, I believe so.
There's one representing death.
All right, let's see. We can take a look. There are a few more here. This is quite a long list, and Stellarium does have the kind of structured outlines, but unfortunately it doesn't have the artwork for all of these, though that would be great. We have Ojibwe constellations as well.
And the Ojibwe people are from Canada and the northern USA. And we see some of these constellations representing animals such as the crane. We also have, let's see, a great panther. We also have a moose.
Yep. And I believe that these are, oh, here we also have Southern Hemisphere ones. All right, let's see if there are any other that we want to take a look at. Okay. Was not using this before, but I can zoom the field of view out here a little bit and see things kind of as a broader part of the sky.
And when we zoom out to more of a sky chart, we're able to see like the North Pole or the South Pole, depending which hemisphere we're looking at, in the center, and then towards the horizon going around the edges. And I believe Miranda wants to share something about a constellation. Miranda, would you like to speak?
Yeah, sure. I looked into the Ojibwe culture about constellations for a little. They sort their constellations by seasons, and there are ones that represent each season. In particular, for example, the moose that we're seeing on the screen right now, actually at the center, represents fall because in Canada and northern USA, they hunt mooses during the fall, and it's representing hunting season. And the panther, I think it's representing a black panther, would be representing the spring, and hence is categorized into the spring part of the sky because the tail of the panther is supposed to protect the people from slippery ice when they go into working on ice to get fish and stuff.
Yeah, so unfortunately I have a list of just what actually has the art on the program. I believe that they're mostly Northern Hemisphere. Let me check again.
We're looking to see if we can answer this question and screen share what is available in the program. You also are able to manually add files with additional constellations or star lore which aren't in the default, but it may be that these particular ones aren't in the default package that are available.
Yeah, I think we've looked through most of what we have in ones that have the full illustrations.
Okay, at this point, I think we're going to start opening up for questions as well. If any of the attendees want to ask questions about like either particularly related to these constellations that Kate and James are showing over Stellarium, or just like general astronomy questions if you're curious about space and stuff. All of us here are astrophysics majors or like astronomy minors and stuff, so we're all decently qualified to answer whatever questions you have. So yeah, feel free to ask away.
Perhaps while we're waiting for questions, I could just briefly show another resource I really like for looking at constellations and how different cultures saw different constellations. There's this lovely website, Figures in the Sky, where you can look at the same patch of sky and see how different cultures viewed it. So it starts with the Orion here that Nathan showed, and you can, if I can find the Egyptian one, I don't see it. Oh, here it is, right here. We can have a look at the sky map of oops, where'd it go? Of Sa, but you can also, we could have a look at how the Ojibwe people saw it, which is a little bit similar to the hunter. This is the winter maker. And this is nice. It has a few different patches of sky. I really like this resource.
So one of the questions was whether students have a favorite constellation and why. I guess I'll go first. I particularly like Orion, not necessarily for the constellation itself. I think the constellation itself is kind of like weirdly shaped and doesn't really make a whole lot of sense, but I enjoy looking at some of the stars in it, as well as the nebula. So the star Sirius is one of the brightest stars you'll see in our sky. And when it's low on the horizon and when you look at it through a telescope, you will actually see the effects of the atmosphere causing the colors to shift. So it will look like it alternates between like blue, green, and orange, which is just really cool. And the Orion Nebula is in the Orion constellation and is one of the easiest nebulas that you can view with a telescope, and it's just very pretty. Other students with other favorite constellations, feel free to speak up, or just different reasoning.
I was also going to say the same one, and I have a funny feeling that may be the same for many of us. And I think because it is easy to see, it tends to be more of a winter constellation. And so it's something that I always look and I identify and recognize in the fall, and especially like as we get closer through the semester, closer to finals, it's always interesting to walk across campus. And whenever it's a little chillier, just to have that reminder. And it's nice to see, I think it's a little bit grounding perhaps, just to see overall how the stars move across the sky throughout the seasons.
Yeah, I've just also pulled up Orion here, which I'll add on again that I also really like Orion for a lot of the similar reasons. It's very easily noticeable. I can see it from my room back home in the winter, which is a plus. A close second is Cassiopeia, another pretty easily recognizable constellation, the big W in the sky. If I can remember where it is in relation to Orion. Here we go. Cassiopeia is a really interesting constellation. The only thing that I know about objects within it is that it was the location of one of the brighter supernovae in kind of recent human history in the late 1500s. And the remnant from it that's still there is really stunningly beautiful. So.
Cassiopeia is one of my favorites too. I think partly because my husband's name begins with W, so that's kind of fun. But it also has a really nice story. It's one of the circumpolar constellations, which means as viewed from Haverford or places in the north, it will never set. It's always in the sky. And the story, the constellation myth I learned about Cassiopeia was that it was the seat of a queen. And so kind of the W kind of makes it hard to see the queen. There she is, yeah. And she was boastful about her beauty. And as punishment, she was placed in the sky in a way that she would get tipped on her head once every day, in a very indignant fashion. So I always like that story for some reason.
I would say the one of my favorites is the Big Dipper. And in our astro class a few weeks ago, we did a project, and my group was looking at indigenous star stories. So one of them is called The Bear and the Three Hunters, and it is a story from the Iroquois tribe, which kind of says that we have the Big Dipper, which is a bear, and there are three stars forming the handle, and those are the hunters. And there's a tiny star and a small dog named Hold Tight. And so since in the autumn, when the constellation is lower in the sky, there's blood that drips from the bear's wounds onto the trees, which lead to their color.
Miranda, Julian, do you two have any favorite constellations? It's okay if the answer is no.
I was going to say that I like Gemini because I am a Gemini, and also I'm just fascinated by how can people tell it's two-person. Just as people have said, some of the constellation figures does not make sense, and it just fascinates me.
Okay. Julian, any favorites?
Nothing really. I agree with what my classmates have said. I don't know. I grew up in a big city where I haven't really been able to see the stars because of light pollution, so I don't have a strong connection to the constellations.
Okay. Looks like we have some other questions that were able to be asked in that time, so this is fun. Constellations may have uses for navigation, but are all very Earth-centric and tied to our point of view. Do any constellations actually include stars that are anywhere near each other physically? There is an answer to this, and the answer is kind of a yes. A lot of the stars that many of the constellations are not actually close to each other due to, yes, it being an Earth-centric point of view, but many stars are actually binary star systems. It is incredibly common for stars to come in pairs. So Sirius is an example of one such of a star that is actually two. Karen has noted that Pleiades is actually a constellation where we know the stars are actually all like fairly grouped together.
I think technically it's an asterism, which is like a fancy name for a group of stars, which is not one of the official constellations. But given the topic today, I think we can call it a constellation.
Mm-hmm.
I love this movie. Who found this? This is great. Showing the Orion constellation from different angles.
Yeah, there are, I couldn't find it. I was trying to. There are a few web apps that are actually interactive 3D models of the constellations where you can kind of pull them out from the side and really see how from a different perspective they're completely shifted.
Of course, the other thing is all the stars are moving. They look fixed in the sky, but they're actually moving. And there was a big data release this week of the motions. And so you can use it to show how the constellations will shift over thousands of years and look completely different in the far future and looked completely different in the far past as well.
Another question is there a sidereal second, which is 365 over 366 of a regular second? It might be instead of an over, it might be an either. Is there a website where I can get coordinates for planets and stars at specific local times? Thank you. I do believe Stellarium will actually tell you the coordinates for planets and stars at specific local times if you just put in your location.
There's some nice free phone apps as well that will use the GPS function on your phone and help you.
Okay.
And do you want to talk about sidereal time? Does anyone want to take that one?
I'm good, but Karen, if you want to talk about it, you are more than welcome to.
Well, so remember, this is the difference between solar time and sidereal time is, so a solar day is the length of time it takes for the sun to be back in the same place in the sky. But a sidereal day is the length of time it takes for a star to get back in the same place in the sky. And because the Earth is orbiting around the sun and it moves a little bit every day, there's a 4-minute difference between a solar day and a sidereal day. And you can find converters for these times online, but that's what the difference is between those two types of times.
Okay, one more question. Does Stellarium or the other program noted provide the ability to overlap to see how different combinations of stars have been used by different cultures? I don't know necessarily about Stellarium. Kate or James or Karen could probably answer that, but I know the other website does let you see the same patch of sky with like several different cultures stacked on. I'm not sure if it will let you pick one or two at a time, but it is there.
Yeah, so I don't believe that Stellarium has that functionality natively to it, but Stellarium does have a lot of user-made plugins that you can add, and I'm sure somebody. Also, yes, I believe Karen just sent a link to the chat.
And there is one more question. How soon could we lose a constellation or star explosion? If by that, I mean, I think you are meaning like when would we expect our next supernova? The answer to that is it really kind of depends. Sometime in the next couple, like 1,000 years, probably. Especially for Betelgeuse. Betelgeuse is the one we're kind of looking at and waiting to die right now. That sounds rather morbid. Betelgeuse seems to be in the state that it's about to sort of perish. But it's hard to predict when that will actually happen because stellar lifetimes are very, very long.
Yeah, and the bit right before a star goes supernova is pretty complicated. They lose sometimes their outer atmosphere, they get puffed up. It's a complicated phase of stellar evolution, and so predicting it very precisely is not good. You can read these funny predictions that it's like anytime from tomorrow to 100,000 years from now, and that counts as now on astronomical timescales, but not really now on human timescales. So.
Okay, any other questions? Okay, there's another question. I was curious if there are any movement to zones in the US free of light pollution a la Green Bank for radio astronomy, or is optical astronomy just not so important anymore or reliant on low altitude observation? I believe there are dark zones. They're mostly in like national parks and stuff. Light pollution is fairly harmful to like native wildlife, especially like birds and whatnot. It messes with their circadian rhythms and causes all sorts of like weird issues. That's why like in areas with high light pollution, if there are birds, you can sometimes hear them start chirping at like 3 a.m. Places that this happen include college campuses. It makes it very easy to sleep. But yeah, mostly like national parks and stuff is where you're gonna find dark zones.
So yeah, up on the screen right here is actually a really helpful map where you can take a look at the levels of light pollution. Actually, this is an international map, in fact. But if we look here, there's actually a dark sky area just a few hours away from Haverford in kind of north central Pennsylvania. I believe up here, which is also, I think, in tandem a state or national park. So these, these areas draw, I know these areas draw kind of a lot of amateur astronomers. In addition to, if there are observatories there already, like we have at Green Bank, then it's, I think, more so that the observatories were there first and then the area was kind of brought around it. But ones that are parks seem, I think, to be more geared towards the general public.
Yeah, and if I could just jump in, there's a lot actually we can do individually to improve light pollution issues. It's pretty simple modifications to outdoor lights to make them not too bright, to shade them so they point downwards, not upwards. I'm hoping to try to have an event maybe next year about light pollution on the Haverford campus, and efforts. The facilities have committed to reducing light pollution following a student plenary resolution. So the student governance brought this up last year. But yeah, the link that I provided, the dark sky site, as well as listing the dark skies, gives some advice to what homeowners can do to kind of improve the situation. Every little bit helps in this, and it's actually pretty easy to fix if people just understood that it would be a good idea to have less artificial light at night.
There was concern recently with the satellites sent by Elon Musk as polluters for observation. Any comments? I believe that is primarily going to be messing with optical observation. I think there was a speaker that we managed to have on campus last year before plague struck that is actually on the committee of trying to work on getting that dealt with. There is radio emission as well, which is a bit of a problem. Yeah, it's a bit of a problem, and they're trying to work on it, and it's a complicated mess. Other people might have more to say.
And I'll just note this, and this is just to forward my agenda on this topic, which I'm very passionate about, that there are a couple of issues regarding fixes for this, especially ideas about painting satellites black and things like that, which doesn't really help with radio emission. And in fact, there were still parts of a satellite that you can't paint over, like solar panels that are highly reflective. This is a really excellent and widely circulated image from, I think it's Cerro Observatory. This is an exposure of, do you know how long of an exposure this is?
I don't, but I can look it up.
Yeah, so what we see here is each one of these lines, as a telescope is taking the image and kind of has the shutter of the camera open, every time a satellite passes, it creates a streak across the screen. And anything you're trying to observe behind there for doing science is unusable. So this is from a few years ago when SpaceX Starlink had just their test round of satellites. So a very, very small scale version of what they're hoping to implement over the next decade. And this is from, I think, a single exposure of not very long, so it's a vague time, possibly on the order of an hour, maybe. But nonetheless, by the end of the decade, I believe that SpaceX is intending on sending something on the order of about 30,000 satellites into orbit. And Amazon and some other companies are also trying to do the same. So it's not unlikely at that kind of scale that every observatory,
Yeah.
will not be.
I just found the number here. It's just 30 seconds.
Yeah, wow.
And this was actually, or at least the article here was published in September of this year. The image may have been a little older, but yeah, it's a big concern actually for astronomers. You know, and software can remove these, but then there's only so much you can do before you can't remove anymore. So.
Any further questions?
There is one raised hand. Vanessa Wallace. I guess shall I let Vanessa talk and ask her question?
Sure.
Okay, Vanessa, you should be able to talk if you want to ask your question. But you are still muted.
Sorry about that. Had a cat. Sorry about that. Had a cat walk across the keyboard.
Oh,
Okay.
so as in the cat raised a hand? That's interesting.
You know, it should have been a paw, but
Yeah.
I guess.
One of my favorite Twitter accounts is Observatory Cats. There are people who post pictures of cats at observatories on Twitter.
I'm going to look that up right now.
Okay.
Sorry for that, but thank you so much for this. It was it's been great. Thank you.
Okay. Well, if there are no further questions, I suppose it might be time for us to call it a night. Oh, one more question. Okay. Difference between RA and DEC and AX alt. Why does the latter but not the former change for the moon and Stellarium, please? Anyone want to try to answer that? James?
Yeah, so these are two different forms of how we kind of position things on the sky when we want to refer to where something is. So RA and DEC, which is right ascension and declination, refer to respectively kind of your longitudinal position around the sky, and DEC is the height, the latitude position. So this is just like longitude and latitude on the Earth, kind of a fixed system to the kind of, if you imagine expanding a celestial sphere in all directions. So this is a consistent way that we can say, you know, one star is always at a particular RA and DEC in the sky. And if we want to put those coordinates into a telescope to look at it, we can consistently do so. Alt-az, which is altitude azimuth, is based on your local position. So altitude is the height of an object above the horizon, and azimuth angle, I believe, is the angle between local direction to north and the object that you're looking at. So you can look at an object at one RA and DEC from different places on the Earth or different times, and because the local altitude and azimuth are changing, you'll get different values for that. I hope that's
basically rectangular and polar coordinates, I guess, to make that 2D.
They're both kind of polar. It's just that because one of them is like relative to the ground where you are,
Yeah.
which is tilted, right? But yeah, but yeah.
Okay, well, it looks like there's one more question. Who has a working like an astrolabe? I don't think I do. I don't know if most astronomers use those anymore. Raise your hand if you have a working astrolabe, I suppose.
So just wait. So I want to speak up very briefly. I don't have one myself, but one of my professors, Darren Heaton, he does, and he has one. And it's a really interesting. I want to call it a gadget. I think that undermines its usefulness or all of the pieces of it. However, Darren Heaton is a history, and I believe I'm saying that correctly, is a history professor at Haverford, and I had him in the springtime for a history of science course, and we really did focus on astronomy for the majority of the time. We covered different things like Arabian astronomy, and in that we covered many different things. And I would almost recommend that you be in touch with him, and I can put his name in the chat. And I'm sure he'd be happy to show his off. That is all. Sorry for a short answer, long.
Okay. Yeah. I suppose that will be it. And thank you all for coming and attending our little event. We're all very aware that it's it's digital and not in person. So not a lot of people feel like they want to attend, but we're all very grateful for everyone who does choose to attend. So thank you all again. And I hope you have a lovely night.